Okay, so this question, cheeky little question. The gradient of the tangent on the curve is this. So that means that the gradient or the derivative of the function is 1.36. And it wants us to find the x-coordinate of A, which is the point where the tangent is. So first thing I'm going to do, if this is the function, we need to find the gradient function. So that means I'm going to need to take the derivative of all of these things. So d over dx y squared is equal to d over dx for x. Now you might remember from chapter 8 when we're doing this part here steals a y. This part here steals the x. So that part there is left with 4. Now I can move this away so we will have a gradient function. Okay, and then they will cancel out and I'm left with 2 over y. So that's nice. Now the next thing we can do is replace this section here with 1.36. It tells us what the gradient is at that point. Now when I do this, I'm going to be solving for the y coordinate. So 1.36 is equal to 2 over y. Now, you can either use your old flippity-flop. This one will come up and multiply. Y times this. This will come down and divide, meaning that you'll end up with y equals 2 over 1.36. But if you're not confident, just chuck it in the calculator and use solven. That always works. Okay, so now I've got a function with y. I can now use my original function to find the coordinates. So here, this is the original function that's set out as a set of coordinates. I have a y coordinate. Now, I want to find the x coordinate. So 2 over 1.36 squared is equal to 4x. Again, from this point, you can solve n, or you can chuck it in your calculator by rearranging it. So let's go to the other section of the calculator. Your standard run matrix, bracket, 2 over 1.36, close your bracket, square it, and divide it by 4. Okay, so that gives me 0.54, meaning that our answer for that one is C.